Hello everyone, this is Mo and it's another episode of our User-Centric Design course, episode number 4. And let's get started. So for today, we're going to cover the user object ergonomics, which is the physical aspects of the product. So last time we discussed how we can form a user persona and how can we develop or understand the user psychopathology or basically the psychology of perceiving objects in the real-time world. And now we're going to cover the user object ergonomics, which is basically the physical part of the user interaction. So for today, we need to first cover a few basic points before we deep dive as well in the principles of how to develop that user object ergonomics interaction or dynamic. So first, again, a very simple definition is what is ergonomics, right? Ergonomics comes from a Greek word ergon, which is work. So basically what you're trying to establish here is this work relationship between the human or the user and the object in play or the product in play. So human factors is a body of knowledge about human abilities, human limitations, and basically what do you need to know in order to apply all of these limitations and abilities on the design tools or on the designed object that you're trying to design. And here again, it has to be safe, it has to be comfortable, and it has to be effective, which basically are the three bubbles that you see here. So whenever we're talking about ergonomics, whatever we're going to talk about the user object interaction or the physical interaction between the user and the object, we're going to talk or cover ergonomics, or basically this is equating to ergonomics. And the human or the user, again, because we said human is not always the case, but the user in this case needs to be able to apply or will be able to use the object within the user limitations or human limitations. It has to be done safely. It has to be done comfortably. So whenever these three are there, like this triangle of needs, let me put it this way, this is basically the ergonomics, or basically how you are gonna affect the user object interaction from the physical standpoint, not the psychological standpoint like we studied last time. So first aspect is the human abilities and limitations. And again, in order to understand human abilities and limitations, the best way of doing that is basically understanding every single user. So this is the ultimate dream of any designer, is understanding what is the correct exact dimensions of every exact user. While this is very not practical or unpractical, we need to kind of compromise. The next best thing in this compromise is basically what we're calling anthropometrics. Anthropometrics is basically the study or the collection of measurements of user bodies. And again, in this particular case, it's human, but you're gonna find all of these similar data for any being. Basically, if you're designing this for a dog, like if you're designing a product for a dog, you're going to find anthropometric tables for dogs. If you're designing that for a cat, you're going to find anthropometric tables for cats, and so on. So it's not really for that particular cat or that particular dog or that particular human, male or female, but it's a collection of measurements for these particular user groups. And today we're gonna, since we're talking about user object ergonomics, people are different, humans are different in dimensions and sizes. So there we have to kick in with our like user group terminology. User group means like there is a group of people that share a certain physical property. Let's say the size of a hand, or the size of the head, or size of the breadth of the shoulders, and so on and so forth. And again, the way they're set, like the way we're usually using and like dealing with these anthropometrics are usually through tables, and these tables are talking about statistics. So how we're gonna apply these anthropometric values on a certain group of people, right? So user groups. And in order to establish this how often I'm gonna deal with that particular measurement, there is another word that came to being, which is basically percentiles, which if you studied any statistics in your academic years, you're going to understand exactly what I'm talking about. Like you have like the bell curve of the Gaussian distribution, and you have the different percentiles, where the mid range is the 50th percentile, which is the average or the mean. And as you go to the right or to the left, depending on, you are either on the 5th percentile or the 95th percentile. More or less how you can comprehend that in a very easy way is, okay, what is a percentile? Is the low end extreme of something. So if we're talking about the height of a person, 5th percentile, which will be the shortest 5% of a user group. 50th percentile would be the average, and 95th percentile would be the tallest. So if I'm designing, and here we're going to talk about different types of design and how to apply these anthropometrics in the real world, you're going to use these tables very often. And the way or the methodology we're going to cover in the following slides. But what I need you to understand from this slide is this anthropometrics, because this is a very interesting keyword that you're going to use often while researching a certain user group, whether again it's human or animal or whatever. And in this particular case, you need to be familiar with the word percentiles because and how you're going to apply those. So for example, there is this figure of that man sitting on a chair. You're going to see every single percentile from A, B, C, D through F, and you're gonna understand. Okay, so they're having basically the male percentiles and the female percentiles, which is very important and very different as well because they have different sizes and or like metrics or values. So you're gonna see here that in the table they're saying 5th percentile and 95th percentile. Usually they don't put the 50th because this is kind of in the middle or in the mean. But if you want to calculate it, you could basically add these two numbers, divide them by 2, and then hey, like there you have your mean. And some tables have the mean as well. So while you're researching your user group, and again, this is the first time I'm going to use the term not user, but user group, and we're going to talk about how we're going to establish this user group in a second. You need to understand the different anthropometrics that you need in your product, which is a step that you have to have in your design process. So if you're dealing with a mouse, your anthropometrics that you definitely need to study is the size of the hand, because this is what the mouse will grab on. The length of the finger, for example, would be very interesting anthropometric, and you need to understand, like, okay, which finger am I designing for? Is it the index finger or is it the thumb? If it's the side button or it's the left click button that we definitely use. Am I designing, very important, am I designing for the right-handed people or the left-handed people? And so on and so forth. So abilities and limitations is the first thing that you need to study in the ergonomics or the ergonomic study or the user object ergonomics. And anthropo in this particular case means human, but I've seen it used interchangeably as well with other beings, or like again animals and so on have anthropometric tables. So probably that's like the classic Latin terminology. But again, I'm not a linguistic expert here, but what I'm trying to say is definitely you need to understand that terminology. You need to understand it's a collection of measurements, so it's not designed for a particular person or a particular user or a particular individual. So you will not find yourself in that particular table unless you're the perfect average or you're the perfect 95th percentile. Another noteworthy point to mention here is that these anthropometric tables differ from region to region, country to country. So if you're designing something, let's say in my case, I used to design a lot of the products for Egypt. And in this case, when I was tapping into some of those anthropometric tables, I didn't find them very relevant to the Egyptian population, especially for a specific like age group, right? So be aware of this difference, and if there is something that you cannot find because I don't know, like the study was done in the U.S. and you want to apply that in another country, be aware of this, and you might actually need to do a little bit of research yourself. If you don't have it available online, you might need to, I don't know, call one of these like government offices. They might have something like this for their population studies. Okay, so how can I apply these nice numbers to my again of the anthropometric tables to design? So here, like you have basically three cases if we can simplify it. Either you design for the extreme, or you design for adjustability, or you design for the average. And basically we have three examples very clearly like set here. And here, design for extreme is you're gonna design for the largest percentile in a specific scenario, like the head clearance in the car. This is usually designed for the 95th percentile because you do not want your tallest guy or tallest lady to bump into the car chassis while he or she is entering. And I said something very interesting right now. So male and female, as we said, male percentiles, 95th percentile are higher, right? So if I'm designing for the extreme, I'm gonna pick the 95th male. And if I'm designing the other way around, the other extreme, the smaller extreme, I will take the 5th percentile female. So when I'm designing for the extreme, I'm gonna take the tallest guy and I'm gonna take the shortest lady. And in this case, now I design for the extreme really in my design. And here we're talking about the second example, which is the car seat to pedestal distance or to the pedal distance. So if I'm designing the chair, and again, the chair I know in the car is adjustable, but let's assume for a second it's not. I will design for the shortest lady. In this case will be the 5th percentile. And again, back to the same example, we could basically say the actual office chair is designed for adjustability. So this is example number 2, or like principle number 2. So design for adjustability is you're gonna again take the range of 50th to 95th percentile, and I'm gonna make sure that my chair lever or my chair hydraulic piston can cover this entire range. Is that exactly done like to the dot, to the millimeter in every single design we see in our lives? No, because we have as well the cost factor in play, and there's of course some standardization factors. So for example, if I wish to have a 105 millimeter range worth of a piston, I might not find this in the market. I will only find maybe 70 or 80 or whatever. So you will do some compromises here, but the important thing that you will need to focus on is that there is design for the extreme that you will need to take care of. This is in some scenarios very valid, and there is design for adjustability, which is as well in some cases very valid. And the last but not least, and in my opinion, this is the kind of the last resort, if you will, in the design world for ergonomics and anthropometrics, which is designing for the average, which is what you see, for example, at the market checkout counters. So they design the height for the average individual, and that's it. So they do not, it doesn't change in height while you're entering. It doesn't. It's static. It is there. And to be honest, you will see a lot of situations where you are designing for the average. You're not designing for the extreme, or you're not designing for adjustability, because either it simply cannot be done or it is very expensive to do it so. Again, at the end of the day, if we as a design team or a designer kind of individuals would wish for anything, we would wish to get and design that product for that particular individual. Like, you know, the newly 3D printed earpieces, for example. These are like super to use and super fitting in your ears and all of these things. But can you wish, or can you hope in the near future at least, to have every single AirPod, for example, designed for your particular ear? I don't think so. Not at this point in time. Maybe in the future, with 3D printing in the rising, and it's getting more and more common in the industry field, and with the material development in the 3D printing, you might see that in the future. And this will be the ultimate. You will not need to do any of these. You will not need to do design for extreme, design for adjustability, or design for the average, because average does not exist. And in this case, the extreme does not exist, because you are you, and we're designing that for you, that particular person. Okay, so I think this is covering the abilities and the limitations. And again, here we're talking about the physical realm, not the psychological realm that we covered in the previous episode. One thing that you need to as well acknowledge and understand, that you need to define, again, this is the how-to in the definition phase. So define the body dimensions that are important for your design. You need to understand the user group, as we talk. So who are the users I'm designing for? Am I designing for adults or teens or children? Am I designing for thin, not so thin, athletic people? Am I designing for pregnant women, or am I designing for non-pregnant women? And it helps a lot as well to study different anthropometric tables and charts, like the one on the bottom left. Like, you're going to see that the distances of the, let's say, the arm length between the adult and the child are completely different. And this is why I'm always saying, do not just take the adult design and shrink it down to the child. This does not work. You need to study the anthropometrics of that particular user group or user age. If you just took the shortcut and did that, you will end up with kind of a miniature of the bigger design, but it's not really meeting the actual user needs. And I think all of the toddler utensils are well studied for toddlers, and this is why you could see them a little bit fatter because of the grip, because they don't hold the spoon or the fork in the same way we hold it. So even that is taken into consideration. And again, once you define the body dimensions at the user group, you need to define the principle, and you need to agree with your design team on that principle if you're working as a part of a bigger team. Why? Because you do not want to be designing for extreme, and your colleague or your design mate is sitting next to you and designing for the average. And you're going to definitely have some interesting talks down the road while the design might be too late to intercept. Select the appropriate percentiles, and again, definitely this is back to the principle. So if you decided to work on the average, just don't do except the 50th percentiles, which is the mean, like the mid-range. And again, if there is a certain anthropometric table available online, this might be very interesting and very good to use at the beginning in the definition phase. But when you are really going ahead and selecting that SolidWorks dimension or CAD dimension that you are putting in your design as a parameter, be careful to use the one that is really relevant to you, not the one that you picked online because it was just available, because country to country it differs. And of course, accommodate buffers, which makes full sense, right? Because if you are designing for a specific bodily dimension or body dimension, this is kind of the no clothes, no accessories on type of body dimension, which is typically how these studies are done. So be careful to add any clothing buffers, any accessories buffer in that case. And definitely do that. Build a mock-up. Build a prototype. It could be as simple as a couple of cardboard pieces glued or hot glued together, and that's it. Easy, right? Don't make it too sophisticated. You will be surprised when you design something on a computer and then you take it to like a quick mock-up. Sometimes I do this a lot as well with my 3D printer. I just, okay, I do it very quickly. I know, okay, this is the size, this is the average size of the object. If I'm designing something like I'm doing these days, I'm designing something for a toothbrush as an accessory. So I basically put everything together in a very quick crude CAD model, and I just printed very quickly, and I said, oh, that's too small. Like in my mind, this much was a bit bigger. One of the common misconceptions of CAD is that you feel things are bigger because you could zoom in as infinitely as much as you want, right? But in reality, you cannot, right? Like in reality, the object is the object, right? It's either this big or it's not. So used your 3D printing tools, rapid prototyping tools. Again, paper mock-ups are equally fine as well in this case, especially for larger models that you do not want to 3D print for days and days just to realize, oh my God, that's way too big or that's way too small. So this is kind of the how on the abilities and limitations, and we're going to cover that as well in the case study in the next episode. So the next one is basically safety, which is, as you probably understand and very common sense, you need to make sure that your product is safe for use, right? And here is basically, it's the art of predicting and minimizing any risk. So if there is a risk of, I don't know, like an edge being too sharp, you fill that edge. If there is a risk of something going wrong in your design and you know it, you could predict it, you will basically design something in order for that undesirable outcome, when it happens, the risk is lower than it is. Again, you could completely eliminate it. If you can, definitely do. Or if not, and then in this case, you could minimize the risk. And here, there are like three very simple examples, like and like principles as well. Like one is exclusion design, one is prevention design, and one is fail-safe design. Exclusion design is very simple to understand. It's like you're making it impossible for the user to make an error. So like though in the water dispenser, they have this small red button where you need to lift the button deliberately and usually in a very uncomfortable angle in order for you to press and release the hot water. This is something making it, I would say, nearly impossible to make that error of pressing the hot water release without intending for that to happen. And this is particularly handy if you have toddlers, which are very active and very imaginative in the ways in the way they're like dealing with objects around them. So everything for them is a toy. So they could just go and play with, and they typically do that, play with the cold water. And they realize very soon in the game that they cannot do the hot one, thanks to the design of that small red lock. So the second is prevention design. You're just making it difficult for the error to happen. Like the very good and simple example of the rails, the stair rails. The stair rails are there to prevent to try to prevent the error from happening, which is basically you falling off the stairs. But if you want to, you could still jump, right? You could still like, okay, let's do it. Like if you have a death wish or something, you just like, oh, you could jump over, right? So it's not impossible, but it is definitely hard. It's definitely difficult. You need to jump over something. And this is the simplest example. And again, use your imagination, and in whatever design situation you're at, think, okay, is this a safety risk? Could this hurt someone? Could this possibly, if used inappropriately, and inappropriately is a very key word here, because if you're using the product like in an appropriate way, usually you don't have an issue. But if you're using it in out of context, think, okay, I'm using that particular device in like a dry environment, and okay, that's like the product will work, right? If it's an electronic device. But think if you're using the product and it's raining. This is an out of norm like context, or at least in Egypt it is, right? So in other countries where it's raining a lot, For them, that's the norm. And in this case, they designed for that actually originally. They don't think about it as an afterthought like sometimes I do about rain, right? So think about that and apply it. The last but not least is the fail-safe. If the error is going to happen no matter what, like for example, like car accidents, God forbid, right? So they happen, right? Like it or not, they happen because of like human errors, because of like slippery roads, because of whatever reasons. So what if the error is gonna happen and it's inevitable? What can you do about it? How can you prevent the consequences of that error in your design? And in this case, it's the airbag, right? So if the accident is gonna happen and you have your seatbelt on, the airbag will gonna be like it will act like as a reduction of risk factor in the formula of having the accident in this case. And this could definitely save a lot of lives. So again, we studied the abilities and the limitations. We studied the safety part. And now we're going to talk about the comfort part. So the comfort is anything, like literally anything that you can do as a designer in order to improve the comfort of your product, the comfort of use, the comfort of interacting with from a physical standpoint. Again, we talked about the psychological part before, or the psychopathology of the perception of the object, planning, etc. in the previous episode. So right now we're talking about the physical aspects. And here, first thing you need to do is something called a link event analysis, which is basically a very simple flow chart, if you will, of if I'm the user, what I'm gonna do. Okay, let's say keyboard. Step one, what I need to do is like I take the keyboard out of the box. So is that event easy to do? Can I take it easily out of the box? Can I take the zip tie or the wire tie easily out? Can you plug and then I'm going to plug it, event number two, and so on and so forth. You take it step by step from the unpacking to the use of the product, and you see in this nice flow chart, usually we call it the happy path, which is if everything went well. So, and then you're going to see, okay, can I improve the comfort of any of these steps? And then you do the error path. What if the user, while unpacking, flipped the box because I don't know, like the packaging has is mirrored. So the front and the back of the package has the picture of the product. So it doesn't have a signifier keyword from the previous episode to tell me this is the front and this is the back. So face this way when you're taking it out so the keyboard does not fall on the ground, right? So all of these events, you need to link them again in the happy path, which is if everything went well, and in the non-happy path or in the error path. And in this case, you just highlight or circle in your very big whiteboard with the tons of sticky notes like we always do. And you say, this I could increase the comfort in, this I could increase the comfort in, and so on and so forth. And in this case, you will see a lot of these things like kind of popping up. And again, there is a lot of things that you could see and anticipate, and there is a lot of things that you will not see unless you prototype and you will actually touch and feel and hold the product in your hand. Like in this gamepad, or this, it's not actually a gamepad, it's a control unit of a certain machine, I guess, if I remember correctly. But here you could see the curves and the fillets. All of these curves and fillets have been done or have been designed to make sure that there's comfort, right? Because all of these are additional costs in the mold and in the plastic and all of that, right? So why do I do this? I do this because it increases the comfort. One of the interesting things as well that we're commonly facing in badly designed products is the text. So the text, people just decide they're super creative and they're doing a lot of creative work with the design and the design of the object, that they actually cannot stop themselves and they do a little bit more on the text side. So text is not where you need to get creative unless you're a graphics designer, which is not our design team at this case. So you do not want to go over like artistic with the text on your products. You want it to be clear. You want it to be very readable from a distance, especially if that distance is you cannot change. Like for example, on the dashboard of the car, you do not expect the user to come close and squint and to see your very nice artistic font that you're using, right? So while it might add some nice dramatic effect on the product, but you're not really helping the user that might be drowsy while driving the car, or like early in the morning or late after work after they're done with their I don't know, like a very long like shift at work, etc. So you do not want that. So some guidelines is use uppercase if it does not destroy your theme or your aesthetics. Bright colors on dark backgrounds never fail. So black, like black background, white text is the ultimate. Of course, if that's not too much of a contrast, play with these a little bit, but be careful not to be a little like don't take it overboard. Don't overdo it, right? And one of the good things that you need as well to realize that sometimes the graphics wear off. So especially text. Imagine, if you will, like your printing process, and see whether this text will kind of wear out after some time or not. So just keep that as well in mind. And what is better than text, in my opinion, is symbols. Symbols are international. They are as a universal language. Everyone, without changing the language on their newly rented car in a new country, if you have a rental car, usually the first thing you do, you go to the languages and you change that to your preferred language, right? But how can you navigate there? Usually you do this using the symbols and the signs that are international, like the back button, like the on button, like the like audio button in this case, etc. So symbols are much better than text. Use them as often as you can, and do not invent your own symbols unless you have to, because most of those symbols are already invented, unless in our case we had a similar scenario where I had to design a symbol for compartment opening, right? So this was something that we didn't have. It was not existing. It was not universal yet, and it took us some effort to design that particular icon to be simple enough to read as like open door and closed door, and we ended up using something on actually the app, not the actual product, because we didn't want to have it hard coded on the product itself. But the idea is simple. Basically, do a link event analysis, go through the happy path, go through the other paths to the product use, highlight the comforts, the comfort enhancement sections, if you will, and see if you have any text, if you have any communication issue with the user that might arise from these texts. How can I make them bigger? Can I make them clearer? And if not, use as well some product symbols and some universal symbols if you can. And if not, you could invent as well yours, but be careful in, again, your creativity level here. Make it as simple as possible. And of course, if in doubt, hire a graphics designer. This is their job. They are best at it. They're like, you do not take a shortcut. You're a product designer. This is your area. If you can do it, and you can definitely convey the message through your user group in the one of the product reviews with your interview people, just go ahead and do it. But if not, don't shy away from hiring a designer, a graphics designer with the right experience for that one. Okay, so with that, we can basically say that the theory part is over, and now we're gonna just do the summary. And next episode, we're gonna cover the case study, which I'm really excited to share with you guys. And again, I hope this will crystallize all of the theory that we've talked in the past 4 episodes. But right now, we're gonna do the summary. So the summary of what we've discussed basically was, we discussed a little bit on the user definition, which was how to say this is the user, how to entice your brain or trigger in your brain this what is the user, who's the primary user, secondary user, direct user, indirect user, all of that. And that is for us, that's like the step 0. And with that, you go through the product market fit pyramid from the lean product playbook, and you could say, this is my product with the need importance diagram, and this is the feature set from the must-have, performance, benefits, and the delighters. And once you understand this is my product, you understand as well this is my specific user group. And in this case, you go ahead and develop your personas. The personas, again, are done through interviews. They're done through interactions with people until you build and understand these are my users that I'm gonna address that product to. And after doing that, you need to define the right fundamentals from the psychopathology standpoint, which is the psychological perception of the objects, affordances, signifiers, constraints, mapping, feedback, and conceptual model, and define as well for your user the ergonomics part, which are the anthropometrics, the safety, and the comfort, which is the physical part of the design. Again, this is the theory behind UCD and how I'm applying UCD in my day-to-day designs in Sand and in my my other day job. And in this case, what I can definitely tell you, this is not the design process, but this is kind of the underlying principles throughout the design process. And the design process, we're going to cover it in a separate session with the actual double diamond phases, all of that. And I'm going to be super happy to deliver that training. I love it. And I love giving that course myself very much. Like, it's one of my close to my heart courses. But this UCD summary, you will find these key terminologies across the process, but I will not be covering these fundamentals again, because we already covered them here in this course. So with that, I'm gonna leave you, and the next episode we're gonna take the case study. The case study is very interesting, and it's one of the cool projects we've worked on in Sand. I'm gonna introduce the product. I'm gonna introduce the different principles that we have applied from the UCD or user-centric design course that we've studied together in the past 4 episodes, and I hope you like it. So with that, thank you so much, and see you next time. Bye.